Okay, let's get into it. We are doing a deep dive today on some serious internal hardware. It's the Bluefish444 KRONOS K8.
hmm
This is all about understanding really the core of professional video acquisition and playout. Why one PCIe card can cost, well, quite a lot.
Exactly. I mean, you look at the KRONOS K8, it's sitting around, what, $5,500?
Yeah.
So you're clearly not just buying a standard capture card here. This is a serious developer platform. It's designed specifically to bridge DCI and UHD workflows across different formats.
Like broadcast routing, post-production.
Yeah, broadcast, complex posts, live events, even video over IP. It's built for that heavy lifting.
Okay, that price tag definitely signals mission critical. But hang on, for that kind of money, why not just, rely on an external server setup? What's the real advantage of cramming all this power onto one single card?
Well, it really comes down to efficiency. Architectural efficiency and speed, mostly delivered by dedicated silicon. The KRONOS K8 basically turns one PCIe slot into this sort of modular real-time routing engine.
How does it do that?
It completely decouples the I/O workload from the main computer CPU. The huge data throughput, the capture, the playout that's not happening through standard software processing. It's using dedicated full duplex DMA.
Full duplex DMA. Okay, that's the key piece, isn't it?
Totally.
So it can grab and send massive amounts of data simultaneously to and from the computer's memory without hammering the CPU.
Precisely. And that dedicated pathway is what enables its sheer connectivity. We're talking 8 independent and simultaneous 3G HD, SD, B, and C connectors.
8 of them.
8. And crucially, every single one is bidirectional.
Bidirectional.
And that's a deliberate design choice. You're not just capturing, say, 4 feeds. You could be capturing 4 while simultaneously playing out 4 others, all at the same time.
Right, that bidirectional thing really unlocks the complex workflows. And, okay, performance ceiling. We're talking DCI UHD 4K at 60 frames per second, capture or playout, achieved via quad-link SDI. Now, quad-link sometimes feels a bit legacy, especially with 12G SDI becoming more common. Why stick with quad-link here?
Well, the quad-link approach really ensures maximum signal fidelity and stability, especially when you're running all 8 streams concurrently. It maximizes the I/O density reliably.
Okay, stability.
And when we talk speed, the latency they quote is sub-unfield or frame.
Subtrain latency. Wow.
Yeah. So if you're not deep into live production, that basically means you can process an incoming signal, slap graphics on it, and send it back out before the next video frame even fully arrives.
Which guarantees that smooth sync you absolutely need in live broadcast.
Exactly. It's critical.
And the signal quality itself, how's that maintained?
It uses a 12-bit video processing path internally, plus this specialized 4x4x33-bit color matrix for really high-fidelity color processing.
Nice.
And they've also built in support for 16 channels of embedded SDI audio I/O, plus Dolby Digital pass-through. So the audio side is covered too.
Good, good. Let's talk workflow adaptability. This is often a big headache, right? It's an internal PCIe card, full height, 2/3 length, fits an 8-lane slot. But the software side,
fully cross-platform, Mac, Windows, Linux. But maybe even more important for, say, high-end post-production or smaller setups is the Thunderbolt expansion compatibility.
Yes. That's a huge plus for flexibility, especially in smaller facilities, isn't it?
Absolutely. You can use external Thunderbolt enclosures, like the ones from Sonnet, for example, and put this KRONOS K8 card alongside another PCIe card, maybe a fast SSD drive or a RAID controller.
So you can build these incredibly fast, kind of bespoke, multimedia workflow solutions without needing a massive server rack.
Exactly that. Plus, they bundle in their in-store acquisition software for free and a cross-platform SDK. So developers and system integrators can get going right away.
Let's zoom in on one specific hardware feature that really shouts live reliability. The 4 hardware downstream keys.
Yes.
These are basically dedicated graphics processors built right onto the card.
That's it. They let you handle real-time titles, bugs, lower thirds, all those live overlays without putting any extra load on the host computer's CPU. It's all done on the card.
Crucial for live. And backing that up, you mentioned safeguards.
Yeah, there are also 4 high-performance bypass relays. This is kind of the physical panic button for broadcast engineers.
Okay, explain that.
If the whole computer, the host system, completely crashes during a live transmission,
Oh, no.
These relays physically lock the input signal directly to the output. They bypass the dead computer entirely.
Ah, so the signal keeps flowing, no black screen.
Exactly. Signal continuity is maintained. It's a really vital layer of hardware redundancy.
Makes sense.
Yeah.
So ultimately, you're looking at a card aimed squarely at broadcast graphics, high-end post, DI, QC, demanding streaming. Pretty much the whole gamut.
And if you connect all this back to the bigger picture, it's this unique combination, handling 4K 60 across multiple platforms, those 8 simultaneous dedicated bidirectional feeds, that incredibly low latency. That's what really underpins the reliability needed for, the next generation of real-time production.
It definitely brings up a core question for you, the listener, to think about. When you consider these essential hardware features, the full duplex DMA, those high-performance bypass relays, how does relying on dedicated physical architecture like this fundamentally shift the reliability equation compared to, say, purely software-based solutions? That feels like the key difference when you move from consumer gear to professional infrastructure. Something to chew on.